Hello everyone, welcome to iRash Academy. In this chapter, we are going to learn how to perform subnetting based on the network requirements on Class B networks. Welcome to the video. Welcome to CCNA 300-301, Implementing and Administering Cisco Solutions, Chapter number 56, Subnetting on Class B Network based on the network requirements. Learn CCNA with iRash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. Let's talk about the basic requirements. In the last video, we have learned how to do the subnetting on a Class C network based on the network requirements. And in this chapter, we are going to learn how to perform subnetting on a Class B network based on the network requirements. So the basic requirement that you need to know for the subnetting is same for whether it is a Class C network, Class B network or Class A network. So let's talk about the basic requirements that you need to know before start the subnetting process. So the point number one, you need to understand the basic IP addressing such as IP address, subnet mask and default gateway. Then you need to understand classes of IP address such as Class A IP address, Class B IP address, Class C IP address, Class D IP address and Class E IP address. And the third point, you need to know the numbering conversion. And what are those? It is binary to decimal conversion and decimal to binary conversion. And the fourth point, you need to know how to subnet on Class C IP address. Yes, Class C IP address subnetting is very simple. And if you already know how to do the subnetting on Class C IP address, then you need to follow the same rules in Class B and Class A IP address. So in the last video, I have talked about subnetting on Class C IP address. So if you didn't watch that video, go to the CCNA playlist, find out this video and watch it before you do subnetting on Class B network. There are videos available in the playlist regarding the IP addressing, classes of IP addressing and numbering conversion system. So you can watch those videos and understand the concept, then come back to this video to proceed the subnetting on Class B IP address. So welcome back to the iRash Restaurant Group. In the last video, we were talking about the iRash Restaurant Group. It is the new restaurant group started in New York City, United States of America. Initially, it has a head office and 5 branches. At that time, a Class C IP address were enough to provide the network connectivity to all the branches and the head office. Now, iRash Restaurant Group, it is expanding their business into all over the USA. So as part of that, they need to start many new branches across multiple cities. So this Class C subnetwork is not enough to provide enough IP address to those branches. So in this situation, we need to expand the network into a Class B network, so that more IP address is available to provide the network communication. So the network architect of iRash Restaurant Group redesigned the network. He modified the Class C network into a Class B network, so they can accommodate all the branches into this network. So they redesigned their network as shown in the picture. Here you can see the iRash Restaurant head office, which is in the New York City, and in New York City itself they have 10 branches. And at Los Angeles, they have another 10 branches. Then at Chicago, they have another 10 branches. Then at Philadelphia, they have another 10 branches. And at Dallas, they have another 10 branches. And they assign one IP address which is called 192.16.0.0/16 network to all these branches. This is a Class B network. The /16 indicate the CIDR indication of Class B network, and which is coming with a subnet mask 255.255.0.0, and this is the CIDR indication of Class B network. So this IP address we need to divide into multiple subnetwork and assign to all these branches. So if you are a network engineer who is working at iRash Restaurant, it is your responsibility to do the subnetting and assign the IP address to all the branches accordingly. So let me show you how to do that things. So we have learned the 3 steps of subnetting process in our last chapter. And what are those? The point number 1 is convert the number of networks into binary and find out how many bits required for that. The point number 2, reserve bits value in the subnet mask and find out your increment. And point number 3, use your increment to generate the network ranges. So I will show you how to do that in each steps. Let's start. Let's talk about the conversion of the number of networks into binary. Here, first of all, you need to understand what is the total number of network required. Then you need to convert that numbers into binary. So how do you know how many networks you needed? For that, you need to go back to your network diagram and understand from there, or your employer will provide you how many networks you needed. So let's go back to the network diagram and find out how many network we needed to do the subnetting. So this is the network diagram you can see at the screen. Here you can see the Irish restaurant group is expanding to 5 cities, which is New York City, Los Angeles, Chicago, Philadelphia and Dallas. And at New York City you can see there are 10 branches. And at Los Angeles there are another 10 branches, at Chicago another 10, Philadelphia another 10 and Dallas another 10. And total how many branches you have here? You can see 10 plus 10 plus 10 plus 10 plus 10. So total number of 50 branches we have. So that means we need 50 network. For each branch we need one network. So we need 50 network. So the number of requirements we needed here is 50. Now let's go back to the subnetting process. So what is the answer we got? What is the total number of network required is 50. And then convert the number into binary. So how to convert this number into the binary? For that, let me bring the binary to decimal conversion table. Here you can see in the screen the conversion table. So in this table, let's find out what is the binary value of 50. So here the first column is 128 and it is more than 50, so I will make it 0. Then the second one is 64, that is also more than 50, I will make it 0. Then the number 32, it is coming lesser than 50, so I will make it 1. And to reach 50 we still need 18. So next one is 60 and I will make it as a 1 because 16 is lesser than 18, and now we still need 2 to reach 50. So next one is 8, that is greater than the value 2, I will make it 0. Then 41, that is also greater than number 2, I will make it 0. Then number 2 exactly, so it is matching with our requirement, I will make it 1. Then next one is anyhow 0. So the binary value of number 50 is coming as 1 1 0 0 1 0. This is the answer. Now let's find out how many bit is required to get the decimal value of 50. So our value is 50 here, and how many bit is required? Just calculate the number of bits from our answer. This is the converted form of binary. So 1 2 3 4 5 6. The answer is 6. So to get number 50, we need 6 bits. Okay, so this is our answer. Now let's go to the point number 2. Reserve bits in the subnet mask and find your increment. So for that, first of all, find out what is the subnet mask. Then convert the subnet mask into binary. So here, what is our subnet mask? First of all, what is our network provider? So our network is 172.16.0.0/16, and this 16 indicate the subnet mask. This is the CIDR format. So our subnet mask is 255.255.0.0 because this is a class B network. So this is the class B subnet mask. Now convert the subnet mask into binary. So the first one is 255. So convert this 255 into binary. So when we convert this 255 into binary, we will get the answer all 1 in the binary conversion table, because to get the 255 you need to add all this value together, then only you are getting 255. So you need to denote each value as 1. So our answer is 255 will indicate as 1 1 1 1 1 1 1 1. Okay, 8 bits and all the bits are 1. Then the second one also 255. So I will make it as a 1 1 1 1 1 1 1 1. Third bit is 0. 0 indicate all the value in this binary conversion table should be 0. Then only you get the 0. So let's write 0 0 0 0 0 0 0 0 8 0, 8 bits. Then again 0, that is 0 0 0 0 0 0 0 and 0. So this is the binary conversion of the subnet mask 255.255.0.0. Now in this subnet mask you can see all the portion that contain 1, which is indicate the network portion, and the portion which contain only 0, which indicate the host portion. So in this subnet mask, to get the 50 network, you need to sacrifice some of the portion from your host and move into the network. So how many subnetwork we require? That is 50, this one. And to get the 50, you need at least minimum 6 bits is required. So I am going to convert 6 bits from the host portion and move that to the network portion. So at which point I need to do that thing? You need to start it from the beginning of the host portion. So where is the beginning of the host portion? It is this one? No, it is this one, because till this area there is a network portion, and from here the host portion is starting. So you need to start from here. So here I am going to take 6 bits and convert into network portion. So all the 0 should be converted to 1, because 1 indicate the network part and 0 indicate the host part. So here the 6 bits I am going to take 1, 2, 3, 4, 5, 6. So this is the boundary. So I will convert all the 0 into 1, that is 1, 1, 1, 1, then 1, 1, 6 bits. 6 bits converted into network part. Then remaining 0, 0. Then the remaining 0 we will continue as it is. And this portion will remain as it is network part. So 1 1 1 1 1 1 1 1 dot 1 1 1 1 1 1 1 1. Okay, so this is our new subnet mask we need to use in the subnetwork. Now next step is convert this one into a decimal. Here all the one will go to 255 dot, then the second portion all one, then it also will go to 255. Third one we need to convert into the decimal. So let's use our binary conversion table and convert into decimal. So I am going to distribute all this value into the binary conversion table. So it is 1 1 1 1 1 1 then 2 0. Okay. Now to get the decimal value, we need to add all the value that indicate the bit 1, then we will get the decimal value. So we need to add 128 plus 64 plus 32 plus 16 plus 8 plus 4. Then we get the value 252. Okay, then next portion contain all 0, then we can indicate that 0. So this is our new subnet that we need to use at each subnetwork. So here I have cleared the screen and add all the result properly. So the number of network requirement is 50, and when we convert that we get the value 110010, which is contain 6 bits, and when we reserve that 6 bits in the subnet mask, we get the new subnet mask as 255.255.252.0. Now the point number 3, use your increment to generate the network range. So how to generate the network range? Let's see that thing. For that you need to find out the increment value of your network. How to find out the increment value of your network? For that you need to go back to your subnet mask and convert into that binary. So here 8 ones, then 255 stands for another 8 ones, then 255 stands for another 8 ones, then we have 252, which is this value, then we have 00000000. Okay, here when we talk about the increment value for the network, let's find out what is the least value of your network portion. Here, as we know, all the 1 indicate the network portion and all the 0 indicate the host portion, and here the least value of network is this one. Okay, this one. So what is the decimal value of this one? To find out the decimal value, just distribute this value in our binary conversion table. Then what we will get? 1 1 1 1 1 1 0 and 0. So this value of 1 is exactly this one, which is equal to 4. So 4 is our increment. 4 is our increment. Now we need to use this number to generate the new networks. So let's see how to do that thing. So we get our new subnet mask, which is 255.252.0. Okay, this is our new subnet mask. Network increment value what we got is 4. Now generate the network. So to generate the network, what was our IP address? That is 172.16.0.0/16. This was our network. Okay, now use this increment to generate the new network as part of the subnetting. So what is the first network would be? it would be 172.16.0.0. This would be my first network. Now how to find out the next network? For that you need to add this number 4 into your existing network. And where I am going to add this number 4? If you look at the subnet mask, you can see these parts are indicating the network and this part indicate the host. So where you are going to add this number 4 to get the new network? Exactly at the least value of network portion, at this part. So third octet. So I will add 4 to the third octet to get the new network. So my next network is 172.16.0 plus 4 and we get 4.0. And next network, add again 4. So 172.16.4 plus 4, 8.0. Then repeat the same process, 172.16.12.0, 172.16.16.0. Okay, so in this way just add 4 to get the new network, and this is the starting point of the network. And where would be the ending point? For each network there would be one starting point and ending point, right? So this is the starting point. So how to find the end point, end IP address of the network? For that you need to go to the next network, which is this one, and consider previous IP address as the ending IP address. For example, our next network start from 172.16.4.0. So what would be the previous IP address? That is 172.16.3.255. This is the previous IP address of the next network, right? So in the same way, find out the ending IP address of each network. Here the next network is 8.0. So the previous network I can use as 172.16.7.255. Then this one 172.16.11.255. Then 172.16.15.255. So in this way I can find out all the starting IP address and ending IP address. So each of this network you can assign to each branch, and they can use the IP address available in this network to the devices inside of their network. So here we get multiple network. Now how many hosts they can connect from each network? Or I can ask another question, how many network they can actually get? We can find out using this subnet mask. So what is our subnet mask? 255.255.252.0. So when we convert that into binary, what we get? 1111.1111.1111.1111.1100, then all 0. So how many networks we can get that thing? To find out the network, we can use the formula 2 in the power of n, and n indicate the number of network. So here the number of 1 indicate the network part and number of 0 indicate the host part. So to find out how many network you can get by using this subnet is find out the number of 1. Here how many 1 are there? 1, 2, 3, 4, 5, 6. So our answer will come 2 in the power of 6. And what is that equal to? So let's find out what is the value of 2 in the power of 6 using the calculator. For that, let me bring the calculator here. Then I am going to change that into scientific mode. Okay, it is already in the scientific mode. Here 2 with the power of 6 we can use by using this formula. Okay, I press 2, then use this formula, and what is the power value? It is 6, and it is equal to 64. So our answer is 64. So by using this subnet you can get 64 network. Now how to find out how many hosts I can get by using this subnet? For that we can use the same formula in a different way. Now this time our formula will be 2 into 2 with the power of h, and h stand for host part, then minus 2. And why this minus 2 came here I will tell you. So here 2 and how many bits for the host portion? We can calculate here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 with the power of 10 minus 2. And what we are getting? Let's use our calculator again to get the answer. Here our value is 2, then with the power of 10 is equal to 1024. Okay, so our answer is here 1024 minus 2, and that is coming 1022, and this is the total number of hosts we can use by using the subnet mask. Why we reduce 2 here? Because in each network there are 2 IP address you cannot use and you cannot assign to any devices, and the one is network ID and the second one is broadcasting ID. The network ID is used to indicate that network by the network devices, so you cannot assign that to any devices. In the same way, the broadcast ID, that also you cannot assign to any devices because that is using for broadcasting purpose by the network. So in any network, the first IP address considered as network ID and the last IP address considered as the broadcasting ID. So we cannot use these 2 IP address. That's why we reduce 2 IP address from there. So we get total number of IP address we can assign to host as 1022. So you can use these 2 formula at any subnet to find out total number of networks and total number of hosts. So when we generate the network as per our increment value, we get all the network as showing in the screen. Here you can see there are total number of 50 subnetwork. Our requirement was 50 network. So as per our calculation, we received 50 network. And here in the screen you can see the starting IP address and ending IP address of each network. And you can see the network ID and broadcasting ID of each network. Here you can use the IP address from starting IP address to ending IP address to assign to any network devices, but you cannot assign the network ID or broadcast ID to any devices. It is prohibited. So this is how you do the subnetting on a class B network. So in this chapter, you have learned how to do the subnetting based on the number of network requirements on class B network. Thank you very much for watching and subscribe to the channel for more videos. Enhance your skills using iRash Academy.